In the previous video, I promised to give you an example. So suppose you have 3 points. So you've got this point here, A. So this is one across, zero in the y direction, and then minus one down. So this point here will be somewhere around here. And then your second point will be three across in the x direction, 1, 2, 3. And then 3 across in the y direction, 1, 2, 3, and then 2 across in the z direction, 1, 2, roughly somewhere around here. So this is your B, and then C would be 4 across, 1, 2, 3, 4, and then 5 across, 1, 2, 3, 4, 5, and then minus 1 down, somewhere around here. So you've got 3 points floating in 3D space. If you have 3 points, then you're always going to be able to create yourself a plane. So in this video, we're going to come up with the equation for this plane. So when you get given this, you're just going to be given 3 points. You're not going to be given this this grid. So when you actually come to do it for yourself, just set up 3 random points. Let's just call this point here A, and let's just call this point here B, and let's just call this point here C. So you're not going to get given a grid. So just have 3 arbitrary points. So we want when you have 3 points. At the moment we've got 3 points. 1, 2, 3. With 3 points, you can always create 2 vectors. So we want to be able to create this vector here from A to B, and then later on we need from A to C. So looking, how would you get from A to B? Well, currently you are at A. How would you get to B? So currently in the x direction, well, currently you are in the x direction. You are currently at 1. How would you get to 3? Well, you would need to move 2 across. So you would need to move 2 across in the x direction. Currently you are at A. In the y direction, you need to move 3 forward in order to get to B. So in the y direction, you would need to move 3. Well, currently you are at A. Currently you are at negative 1. How would you get to 2? Well, you need to move 3. You need to move 3 in the positive direction. So from A to B, this would be your vector. So remember, these are just points. Now from A to B, this will be your vector. So you will need to move 2 across, 3 across in the y direction, and 3 up. Well, to get from A to C, currently you are at A. How would you get to C? You would need to move 3 in the positive direction. Currently you are at 0. You would need to move 5 in the positive direction. Currently you are at negative 1. How would you get to negative 1? Well, you don't need to move anywhere, so it's going to be 0. So these will be your vectors. Remember, when given 2 vectors, when given 2 non-parallel vectors, if you just blindly perform the cross product of the 2, then it's going to give you this vector, and this vector will be perpendicular to this vector, and it will also be perpendicular to this vector. Okay, so now blindly perform the cross product. Performing the cross product will then give you this. So the first one will be I, discard, and just look at these 4. And then the second one would be you looking at J, discard, and just looking at these 4. And then K, discard, look at these 4. And then now compute the determinant. This times this, take away this times this. That will then give you this. And then don't forget you've got a minus here. So the determinant of this, 2 times 0 will be 0. Take away 9. But then, so that would then give you minus 9. You've got a minus and a minus here. That will give you a positive 9, and so on. This will then give you 1. So this will be our normal vector. So hang on, going back one step. We've got a vector here. Perform the cross product. That will then give us this. And this thing here is our normal vector. This is our normal vector. So now that we've got our normal vector, we need to I will continue in the next video. Okay, so we are currently here. We've got our normal vector here, so I will continue in the next video.